Okay, here we go with an example involving implicit differentiation. So we're given the curve 4y squared plus 3x is equal to 2y, and our charge is to find the derivative, dy dx. So we're looking for some kind of expression that will give us the slope of the tangent line at any point on this curve right here. So as we've talked about already with implicit differentiation, we're going to derive the x terms just as we did before. We're going to derive the y terms like the x terms, but remember, because it's not x, it's ugly, and if it's ugly, then we need to use, yes, the chain rule. The chain rule says take the derivative of ugly. Well, y is the ugly, and so we are taking the derivative of y with respect to x. So we need a dy dx whenever we derive a y term. Remember, we have to derive both sides of the equation. Our goal is to get dy dx all by itself on one side of the equation. And finally, if we have multiple dy dx terms, then we need to make sure that we factor dy dx out so that we move down to just one term. So here we go. Again, our formula, our equation is 4y squared plus 3x equals 2y. We're going to derive the y terms like the x terms. So if this was 4x squared, we would say the derivative is, but since it's 4y squared, we will make that 8y. And again, because it was a y being derived, we need the chain rule, so we need our dy dx. Now we take the derivative of 3x. We all know that to be 3. And we have to derive both sides of the equation, so we now have to derive 2y, and 2y's derivative will be 2. But yes, we do need that dy dx. Okay, so we've now moved everything down to the derivative level. Our goal is to get dy dx all by itself. We have two dy dx terms, so we're going to have to factor out a dy dx after we get them on the same side. How should we get this 8y dy dx over to the other side? Good, you said subtraction, and that's what we're looking for. We're going to subtract 8y dy dx from both sides of the equation. That gives us 3 is equal to 2 times dy dx minus 8y dy dx. And now we can factor the dy dx out from this right side of the equation. So we have dy dx being pulled out. Yeah, we can pull out a 2 as well, but I'm not going to bother with that at the moment. We've got 2 left over because 2 dy dx divided by dy dx is just 2. And then 8y dy dx divided by dy dx is just 8y. Now to get dy dx all by itself, what should we do? That's right, we need to divide. So dy dx is now going to be all by itself on the right side, and 3 divided by 2 minus 8y is our derivative over on the left side.